Can everyone see the slide and am I audible clearly?
Yes, you are audible. Just there's some disturbance in your voice, but overall it is fine.
Should I
So,
switch on the
Pinal,
fan?
just a second. I will just introduce you and then you can start. Guys, this is the fourth session of our lecture series by PhD students. Today's speaker is Pinal. He'll be talking about response surface methodology, and he's been working on this topic for some time now, and he even got a publication out of it. uh, about penal. Penal has been a part of the of a research of our research group since 2017. Earlier as a master's student, and since 2009 he has joined as a PhD student under the prestigious Prime Minister Research Fellowship PMRF program. And without further ado, I'll ask Penal to start his presentation. Penal.
Yeah, thank you, Anup, for the introduction. Basically, RSM is a part of our design of experiment. So first I will explain what is design of experiment, then we move slowly into the RSM. So, hello, good evening, everyone. Firstly, I would like to welcome you all for the lecture series on design of experiment. I will try to keep this session very interactive, so please do participate. So, during this lecture series, I will use term DOE instead of pronouncing design of experiment. So please take a note of it. So let me first explain what is DOE. So DOE is a branch of applied statistics that deal with the planning, conducting, analyzing, and interpreting control tests to evaluate the factor that controls the value of parameter or a group of parameters. So basically, it is a powerful data collection and analysis tool that can be used in a variety of experimental situations. It allows for multiple input factors to be manipulated and determining their effects on, on a desired output or a response variable. If we take an example of a laser, then laser power, pulse duration, frequency, fluence, and lot more other input parameter, whereas the temperature obtained at a different time and space is considered as a output or a response variable. So by manipulating multiple input at the same time, DOE can identify the important interaction that may be missed when experimenting with one factor at a time. For example, if we increase the pulse duration by keeping all other parameters constant, then with increasing temperature, sorry, uh, uh, by all other parameters constant, the temperature increases continuously. But when two different parameters such as pulse duration and frequency increases, then what is the variation in temperature that can be obtained using design of experiment. That way, design of experiment can identify important interaction that may be missed when experimenting with one factor at a time. Uh, Now we see what is the need for DOE. So DOE is basically used for providing answer to the question. So first question is, what are the key factors in the process? So anyone knows what is a Pareto analysis? If anyone knows the answer, he can mute himself or and give the answer. But we learned statistics at some point of time, so we must know what is Pareto analysis. Anyone knows what is Pareto analysis? Okay, so let me explain. So it is also known as the 80-20 rule. It tells that 80% of outcome or outputs comes from the 20% of the causes or input. So this Pareto analysis can be understood by, we can understand by one example. So if you list down all your problems and reason for all your problems, so if you listed 100 problems and reason for problems two, so number of problems is 100 and number of reason for that particular problem is 10. So if you want to solve 80% of problem, then you just need to focus on 2% of the it causes. So that principle is given by the Pareto. That's why it is known as the Pareto principle, or it is also known as the Pareto analysis. The variation in data is neither totally chaotic nor small enough to be ignored. It is a real, identifiable, and predictable statistically. We can easily define many factors of a potential significance, but only few account for a vast majority of a structural variation in the data. Suppose a laser machining process depends on number of parameters such as fluence, pulse width, pulse duration, frequency, power, etc. Out of these parameters, only few parameters that majorly affect the temperature variation. Second is, what is the setting would the process deliver acceptable performance? So once we know the most important parameter, uh, the most important parameter that affects the responses, the next task is that up to to which extent it affects the responses. Third is that what are the key main and interaction effect in the process. The interaction of the important parameter and its effect on the responses. And at the last, what setting would bring about the less variation in the output. Means decide the range of processing parameter and their interaction. Uh, Now we understood what is DOE and its need. So now we see the sources of functional variation. Basically, there are three different types of functional variation, or we can call it as a noise: outer noise, inner noise, and variation noise. So outer noise is the source of a noise which influences the performance as a measure during use under the actual operating conditions. For example, atmospheric temperature and humidity while conducting the experiment. In general, we cannot control the temperature and humidity, but it can. But in the case of clean room application, we can control both, but it is very costly at the same time. Other is variation in supplied voltage while doing welding and vibrations during machining is the example of outer noise. Second is the inner noise. It is an internal change in the product characteristic, such as drift from a nominal hour, sorry, drift, uh, uh, drift from the nominal over the time due to the deterioration for example, mechanical wear, you cannot completely control the mechanical wear, but by adding some lubricant, you can reduce it, but you cannot eliminate it completely. And at last, in the variational noise, it is the variation in the product parameter from the one unit to the another as a result of manufacturing process. For example, manufacturing imperfection, that's why the concept of limit, fit, and tolerance are introduced. I think I have explained the enough reason that why the design of experiment is important. Now we directly jump into the problem and solve it using the different method. So first we see the factorial design of experiment. Let me first explain the difficulty of the problem. For that, let us consider an example. Suppose we want to perform the experiment having three input variables as I mentioned over here, frequency, pulse duration, and power, having five different levels, -2, -1, 0, 1, and 2. In the design of experiment, different levels are always defined like this way only. If there is a two level, then 0 and 1. If there is a three level, then minus 1, 0 and 1. If there is a five level, then minus 2, minus 1, 0, 1, 2. If there is a seven level, then minus 3, minus 2, minus 1, 0, 1, 2, and 3. This way goes on and on. And the response variable that we want to measure are the surface temperature, surface roughness, depth of ablation, width of ablation. And the replication is one. Replication is basically a number of times we repeat the experiment in order to increase or improve the accuracy. So here are the different parameter according to the different level. So here is the five different level of frequency, which is 30, 40, 50, 60, and 70. Five different level of power, 0.05, 0.1, 0.15, 0.2, and 0.25, and five different level of pulse duration in nanosecond, which is 70, 90, 110, 130, and 150. If we want to know the effect of each and every parameter and its interaction on the response variable, we have to conduct 5 raised to 3, which is 125 number of experiments, which is quite high. So, and here I have shown all the combinations. If we fix the frequency at 30 and then the first value of power at 0.05, and we get five different combinations of pulse duration. This is a first five experiment. Then if we change the value of power to 0.1, and same way we change the pulse duration at five different value. So this way we can form the different combination, and all the if we count all different combination, its value is 125. Now just imagine the time and effort. Sorry, just imagine the time, effort, and cost required to conduct this much experiment. Okay, somehow you managed to do this experiment. Then think about the measurement. Surface roughness, depth of ablation, and width of ablation measurement is a very tedious process. Moreover, for the measurement, at least 2 to 3 repetitions required for each sample, and then think about the data generation during the measurement. And the processing this data and representing this data in a meaningful way is another challenge. So, and here I have listed some limitations. First, uh, first one is we need to conduct huge number of experiments and require huge number of resources, time, and effort. In this sorry, in this particular case, we can save the time, resources, and human effort by using design of experiment. Uh, uh, Now I suggest everyone to take a pen and paper, so you will be better understand what's going on in the presentation. So now we see the uh, factorial design with two level and two variable. Okay, so let's take two input variable. One is temperature and another is humidity. So 0 and 75 Fahrenheit is a two level of temperature, and 0 and 35 is a two level of humidity. And the response variable is the comfort level. Here we have made a plot for the temperature and humidity and measure the response variable. Here I have shown the graph, and we have scaled the comfort level at 0 to 10, where 0 is the worst and 10 is the best. So this is a comfort level 0 to 9 and 5. And on x-axis I represent the temperature, and on the y-axis I represent the humidity. So at 0% humidity and 0 Fahrenheit temperature, comfort level is 0. At 0% humidity and 75 Fahrenheit temperature, comfort level is 5. Same way at the 0 Fahrenheit temperature and 35% humidity, the comfort level is 2, and at 35% at humidity and 75% temperature, the comfort level is 9. Please note that from now onwards, whenever I use the term A, it's referred to the temperature and term B refer to the humidity. First, we find the average effect of A and B and then move forward further. So, which is given by, the average effect of A is, first we find the average effect of A, which is given by the average of high level of A and, which is given by the difference of average of high level of A and average of low level of A, which is given by this value, 5 plus 9 by 2 divided by, minus 0 plus 2 divided by 2, which is equal to 6. Same way, we can calculate the effect of B, which is 2 plus 9 divided by 2 minus 0 plus 5 divided by 2, which is 3. We have seen the individual effect of A and B. Now we see the interaction effect. In the given case, interaction effect can be calculated by two different ways. First way is by calculating the effect of B on A, or by calculating the effect of A on B. In order to show the comparison, I have shown the both methods. Let me first explain the effect of B on A. So at low level of B, effect of A is, at low level of B, effect of A is 5 minus 0, which is equal to 5. And at high level of B, the effect of B on A is 9 minus 2, which is 7. So, the effect of A changes across the level of B is called the interaction effect. So, the average interaction calculation. So the average average interaction calculated by average difference between the low level of B effect on A and high level of B effect on A, which is given by 7 minus 5 divided by 2, which is 1. Same way, we can calculate the effect of B on A. At low level of A, effect of B is 2 minus 0, and at high level of A, effect of B is 9 minus 5, which is 4. And the average interaction is 7 minus 5 is equal to 2, which 7 minus 5 divided by 2, which is equal to 1. So from here, we can observe that whatever the way, the final result in the interaction will be the same. On the bottom left graph here, on the bottom left corner, I have drawn the graph of comfort level with the temperature at different value of humidity. So this line is for the 0% humidity and this line is for the 35% humidity. Here we can observe that some difference in the slope. That is mainly because of the interaction effect. As the value of interaction increases, the difference in the slope will also increase. Here the interaction value is 1, so there is a small change in slope. If the interaction value of AB is 0, then this line will exactly parallel to each other. Now we find the value of regression from which we will plot the graph. So from the regression formula, which is equal to B0 plus B1 x B0 plus B1 x1 plus B2 x2 plus B12 and x12. Now the question is what are B0, B1, B2 and B12. So we have already calculated the effect of A, effect of B and interaction. So from that we can define what is B1, B2 and B12. So the average value, average effect of A is 6. So by dividing the 2, we can find the B1, which is 6 by 2 is equal to 3. And average value of P is 3. So B2 is defined by 3 by 2, which is equal to 1.5. And interaction value is AB is equal to 1. So B12 is defined by 1 by 2 is equal to 0.5. So B0 is 0. B0 is average of all these compact levels 0, 2, 5 and 9. So it is 0 plus 2 plus 5 plus 9 divided by 4, which is 4. If we plug this all value in this equation, then the final equation is this: y is equal to 4 plus 3x1 plus 1.5 x2 plus 0.5 x12. This equation we can plot in the uh, uh, this equation we can plot in the Minitab. Uh, So, if we plot that data in the Minitab, so this kind of graph we can observe over here. Actually, I want to show the demonstration of the this experiment that we just I have explained to you. But my Minitab 90 days trial is over, so unfortunately I am not able to show you, but I will try to explain the that thing in the next for the next lecture. So in the next lecture, I will try to give some hands-on experience of Minitab. Then we see the signals to noise ratio and ANOVA, which is analysis of variance. It is a very important tool for the statistical analysis. Then we go into the RSM technique. So uh, first is a 2K factorial design, in which we will see the full factorial design and partial factorial design. Then we will see the CCD based RSM design, which is central composition design based response surface methodology design. Then we see the box function based RSM design. Then we solve some real problem that I have used while writing the paper, and so also try to use some software and understand the problem. Thank you. That's it.
Thank you, Pinal, for this